I didn't document any of it. I had to do that eventually, but made some modifications. We have a voltage selector for the high voltage and a test switch so that I can separate the input of the filaments and the input of the high voltage, because they will tear up a power supply. So I charge this battery up so I can show you what this thing is doing now, because she ain't well. It's running the high voltage. Actually, first let's warm up the heaters. Filaments, turn those on. Let those warm up. I need the help of the battery to get them hot enough. That did not cut down on the light. Are we even on here? Yes. What's going on? There they are. They're glowing now. Now what I will do is I will hook up the high voltage. Also put a emergency button on it because this transistor can blow, and if that blows, the high voltage won't start itself. And you can hear it. I hit the switch for the high voltage, and you can hear the tone change. Yeah, it works great. Alright, so right now you can't hear anything because the filaments aren't hot enough, and what I'll do to get them hot enough is I'll hook this to the battery and that'll give it enough current. But I'm only going to do that long enough for them to get hot enough, and then they'll keep themselves hot with the current flow, because this battery has to supply the high voltage, and if it's and also if those filaments get too hot, this thing buffets like crazy, and we'll talk about that. Okay, where's the sound at? Yeah, the filaments are cooling down. There it is. Alright. Here's the tone generator. We have it on AM 500 hertz. So our radio works, which is great, but it needs new capacitors, new high voltage capacitors that I don't have. Not very selective, is it? It's because this filament's hot. There it is. Okay. Yeah, I hear nothing. It's interesting. I mean, there's the tone, but this knob ain't selecting it out very well. I wonder if that's where my capacitance issue is. I wonder if the selectability has something to do with the capacitance. Oh, we're gonna buff it. Jimmy Buffett. Yep, I heard it. I heard it a little bit. See, it's supposed to be on channel 3, but when I go to channel 4, it shows up. Let's see, what's on the channel 4? This is really dangerous, by the way. I've gotten zapped plenty of times by this radio. And that's what I'm transmitting on. Let's try something. Oh, let's pop this crystal back in and we should receive. Yep. That is a little odd. Why are we like that? Huh. My crystals are not bad. What is going on? Oh yeah, this battery's lost it. High voltage. Huh. Let me move this crystal, see what happens. I think I put the crystals in the wrong place, I'm gonna be honest. No, it doesn't like it. It doesn't like this spot. Yeah, so it likes it okay, but not really. Throw it back to number 4. It likes that a lot better. Let's see what happens in number 5. Receive crystal number 5. I think the radio is cold. Oh, are they numbered? No, they all say 5 on them. Alright. I hear nothing. But we might be cold on the filament. Oh, there's not enough current flowing through this bad boy. Come on, come on. Give me some current. There we go. That might be enough juice. We'll keep it on there. Alright. We got no selectability on that. Alright, we can put this crystal back. I believe what that means is this set needs to be aligned. What happened? Okay, so this is supposed to be 5, 4, 3. there's nothing. We had something, but now we have nothing. What does that mean? I think that went there. Okay, so... Oh, that thing's dead. This battery's freaking dead. Alright, let's take care of that. Let's take care of this battery problem. This sort of give us enough current. This might be a little much. Because if them filaments get red hot, we're gonna hear nothing but garbage. Alright. Battery might be charged enough. It's alright. Hot filaments. Huh. One problem. The high voltage. Oh. Jeez. Huh. 3. There's no buffeting. But also, I'm not receiving anything. Alright, put those back. Oh. Oh. Oh, Lord. Wait. Okay. Alright. This socket must be funky. What in the hell is going on now? I'm getting irritated. Alright. Let's do this. Let's turn this off. Do it like the good Lord intended. But this goes here somehow. Like so. Alright. Not like so. Like so. Mother. I thought I made these jackrabbits long enough. Okay. Make sure the switch is in the right spots. Okay. Turn everything off. Alright. This is a bit scary. Ready, set, go. Oosh. Okay. Red hot filaments. It's gonna sound bad, ain't it? Hey. Hey! Oh, there it is. Just ruin the fun. Just ruin all the damn fun. Okay. I'm gonna have to modulate that. So, we'll do it like this. Oh my god, all these stupid wires are stuck together. Boom. Boom. Okay, we don't need that. I need this. Hook that to the high voltage. And then this. Oh, I'm gonna lose my cool. Okay. And then this to here. Okay. And that to there. Separator switch. Okay. So far, so good. Power supply on. All right, perfect. High voltage works. We got high voltage now. I'm gonna modulate the filament. With my bare hands. Okay. So far, so good. Can't hear the thing though. Oh no. We don't need none of that. Where is... We don't need that. There we go. Let's turn it louder. I guess when I turn it louder, it pulls the voltage down on that broken capacitor. Come on. Where's... the hell? Oh. For some reason, it ain't working. I got them hot. Everybody's hot. I don't even have to modulate the dang filament anymore. I'll just jam that in there. See? Alright. Now we can play. Let's change the frequency to 3 megahertz. Come on, you sack of snap. 3 megahertz. Go to where supposedly 3 megahertz is. And it's nowhere. Wonderful. Just wonderful. Let's check this. This says 3193. .193 megahertz. That was channel 4. Okay. Nothing. Higher voltage. There's a bunch of noise on channel 4 where my... Oh! It's there somewhere. Maybe the 500 hertz. Let's do 400. Huh. External gain. 0. This is kind of odd. We are on our set frequency. Turn the damn volume. I can't turn the volume down. Shit. Huh. Good Lord. What is going on with you? So we have some receiver antenna trimmers down here. Let's see. We want the 4th channel. We want to not get electrocuted. Okay. We're in there, like swimwear. I hear nothing. I think that's it right there. Kind of wondering if the whole not having an antenna situation is my whole issue right this second. Let's see what transmitting does. Oh. That sounded like a short. Yeah, the high voltage crashed. That's not freaking good. Oh no. There's my antenna wire. Just attaching this to the back here. is no good. This is no good at all. This is bad. Oh, God. Oh, Lord. Alright, lower voltage. It seems to be chiller with the lower voltage. But also, still not working. Yeah, it's kind of strange. Had it working earlier, but now it doesn't want to receive anything at all. It's kind of strange. I don't want to move this while this is on. So I could turn it over. I want to turn it over. Supposedly the capacitors under these coils go bad, and that might have something to do with why we're no longer receiving, because when I kicked it up to the high voltage and those capacitors started to short, they would have become even more damaged. The more that they short, the more they get damaged. And that might over time keep us from being able to receive, because these coils are responsible for helping us receive. Didn't I just say I wasn't going to move this like this? It is a boat radio. I mean, you would be out on the water hitting the waves. Let me see what happens if I turn this output off. Nothing. Isn't that hilarious? Turn it over to... Yes. Go back on it. I am, funnily enough, receiving the noise from this light. Damn, these are some long screws. Somebody really tried to do some work on this. Somebody really screwed it up. I mean, they tried to put 120 volts across a 12 volt input. When I bought it, it had a wall plug. Alright, here we go. This is the dangerous side. Whoa, get that solder out the way. Someone in here is responsible. Now my socket seemed a bit weird. Is there high voltage crossing? I think so. So I'm not going to touch it. Is that where we're at? I feel like it's hearing more than it should. Yeah. It should not be hearing this much. On both sides of the crystal, all these capacitors gotta go. They might all be bad, every single one. And this thing having no effect on anything. Should be telling me a lot. Which means I'm probably gonna have to pull these out. And that's gonna be no fun. What I really want to do is build this thing, Carlson Super Probe, and hopefully I can probe around the different capacitors and maybe hear that noise, maybe hear the capacitor shorting out or something. Or I could just do the work, replace all these capacitors and these coils. And what really worries me about replacing the capacitors under these coils is I don't want to destroy them, you know? But I think that's the chance I'm going to have to take because I don't know what else to do with this thing. Great radio, though. Great radio. Let's turn it off, dude. Yeah, we know. Nice. Oh, hey. Didn't even know there was comments. Old radio from who knows when. Before I was born. And it's electrocuted me many times so far. Turn this off. I tell you what, you definitely learn a lot about stuff you never knew when you're trying to fix stuff. Now, if only that knowledge could make me some money. Alright. Let's put the torture device back. Alright. In the optimal spot for setting house fires. Nice. With junk on top. Lovely. So, as a bonus, because we're a little done with this, in order to understand the power supply in the back of this thing, I had to build one myself. Let's see. And if y'all are lucky, I might get electrocuted messing with this thing. Right like that, right like that, 'cause I write like that, I write like power on. Okie doke. I think negative is here, right there, and positive is right there. The lights out. And it just did nothing. What the hell? Oh, it's slightly broken. My bad. Okay, that should be better. Still nothing. Hold on. If I just do this, and put y'all in the dark for half a second. I need to get these diodes together, and then this resistor across these diodes, and it should work. Okay, it's not working. Mother flipper. What even is this wire? Well, this isn't going well. I think I got them together. Why don't you work? Is it because you're not plugged in, you son of a bitch? Oh, God. And it still doesn't work. I love it. I love it. Hello? Are you there? This is kind of weird, because it definitely should be working. Maybe. Oh my God, I'm an idiot. It's not even on. Oh my God, I'm so stupid. Okay. See, I told you guys I can do stuff. Hello? It's supposed to have a switch, an automatic switch, just like this one does, right here. I just haven't put it in yet. It is actually supposed to go where this diode goes, I think. Across this diode, here, and then it gets space also from, oh, right here. I actually, and if you wonder why it's chirping like that, it's because this is a ballast, it's a ballast neon, and when it gets hot, it has a little lever thing that gets hot, and it bends and it touches the other side and it shorts it out. Where's my book? If you would like the circuit, this is the circuit. Can be whatever diodes, whatever transistors. There's a couple nuances to it, but you experiment, you'll get it. But this does a good job at lighting up something like this. Hold on. I am guaranteed to shock myself at least once while I do this. You son of a macaroni. Which actually sounds kind of good right now. Can I get a little bit light? Here, let me see. Prop y'all up. Right. Son of a bitch. Right there. God smack it. I have a phone stand, dude. Alright. Okay, that doesn't hurt. Cool. I'm doing my best. Do not touch the other side, maybe. Where'd it go? This isn't working. We need alligator clips. I mean, alligator wires. Alligator whatevers. Okay. 2 of them. Why'd you turn off? Nobody told you to turn off. It said I'm turning off for your safety. And then I totally ignored it. It's one side. Here is the other side. Okay. Alright, full alligator clips. And they work. Alright. I'm going to alligator clip this barehanded, making me nervous. Why is it not working? Ha! It works. Okay. I told you. Oh wait, no, it stopped working. Why is it doing this to me? Doesn't look that incredible from the front. It's probably too high voltage. And I think the current needs to be higher. Lower voltage, higher current. And then it'll work right. I think it's supposed to be 120 volts or somewhere abouts. If we hook an Arduino up to this thing, we can get pulse width modulation, or if I change some resistor properties, or if I add that transistor I was talking about, I can also change the pulse width and get some different voltages out of it, just in the same way that I get the 100 whatever it says on the back of there. What else do we have that lights up? There's a 2 around here somewhere. What I mainly wanted it for was to run these. That's the main goal. I have this. This should detect radio waves if this thing leaks. So maybe if it comes off, it'll probably leak. Nope. It definitely detects that dang Tesla coil though. And then I have this one I made. I made this one. So let's... This one's way more sophisticated. This one's way more sophisticated than this one. But this one is easier to run. It also... Did I mention how inefficient this one was? This one's really inefficient. This one works off of forward biasing these transistors. And then when the coil pulses, it kicks that bias out. And lets the other switch on, or something like that. Oh yeah, this can go to literally any ground. And then I had this little remote to turn it on. Isn't that beautiful? You can't even hear this one. You can't hear this one because these transformers, you know, like with this one we heard, it was really low frequency, almost like you would hear from your wall, right? Like that kind of frequency. But when you separate the cores of these transformers, the frequency goes way, way, way up, so high that you can't even hear it. And these both put out AC. We also have ones like this. This is the primary side of one of these doohickeys. It would go right here. Use the same high voltage side, but a different primary. This will give us a single wave, and it'll give us really bad DC. It'll give us DC, but with a little bit of AC component. It's really weird. It's like really unbalanced AC. That's what the single pulse will give you. This explains it better. So this one here is like if you took away 1/2 of each of these things, or if you just remove the middle of those. Yeah. But they oscillate back and forth. Doop, 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 doop. It makes the magnetic field go doop, 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 doop. Instead of like doop, 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 whatever. I did not set up today to explain how these things work. I will in due time. But right now, push the button. Ew, my fingernails is nasty. This, I wish I could change the number on it, but I cannot easily. That is a number 5. We will make something with these switches. Probably to change the numbers in that. Definitely have to make something like that. I do have a holder for these. And for the last, oh hey look, I didn't even know I had a working one. I totally forgot. Okay, let's plug this one in and see what happens. Nothing. Okay. Might be the wrong way. That's quite interesting. What is going on here? Okay, so definitely it goes this way. No, it's not on. Weird. What's wrong with it? We got the collector, the emitter. Maybe I am backwards. Yeah, I was backwards. Oh, God. Why is it screaming like that? Ah, there we go. Okay. I am not touching this output. I have whoa, why did it just go high? Oh, it's getting hot. That's why. It's getting very hot. Hello. I thought you worked. The hell? It's not working. What the? Alright. Let's try this. Nothing. Oh, it's only 60 volts. I can feel it though. If I touch this, I'll feel it. Okay, never mind. I think this one needs some work. I can't feel it. It's oscillating like crazy. I know this thing did work at one point because it lit up this bulb. Still nothing. I licked my finger. Well, it must be doing something because the frequency's changing. Oh, what is going on? Okay, that actually sounds a little more dangerous. Nope. What? Ooh, that is really high frequency. Ooh, that's like dog frequency. The current is really high and the voltage is super low. And the transistor is really cool. I'm about to put my tongue on this. Where's my meter? Where's my Peter meter? Here it is. Well, fine then. Be that way. Okay. This is going to give us a crappy AC voltage component. Twelve volts on the output. I refuse to believe it because this is not a one-to-one transformer. Okay? Okay. Set it somewhere on DC right now. There's nothing, but oh shit. Oh Jesus. Come on, dude. Not flipping milliamps. We don't need that, even though I'm sure it's only milliamps of current. 12 volts. That is flipping sad. Okay, what can we do? Alright. Oh, it just turned off. Dang it. Ow! What the hell? What? I am getting burned. That is burning me. What? Jesus. How? This was not supposed to be a Tesla coil. What is going on? Well, that's cool. How many volts is that? Don't know, Dora. Why don't you ask Swiper? Why would Swiper know? Because Boots is buried in my backyard. Oh, dang. Well, it was 100 volts before I... Ow! It freaking burned me again. Shit. I'm sorry, I'm trying to show you guys. Oh my god. I just need, like, a camera on my face. Is what I need. But did y'all see it? It's like 104 volts. Which I think is incredible. Ooh, and that's kind of hot. That's really hot. Let's turn it off. Wait, what else can it do? Can it do this? Can it do this one? Can it do this one properly? Like the other one couldn't. I don't think it'll be able to. It's not enough current. Ooh. So it glows on the back, but it does not glow on the front. It means the voltage is still too high. Current is still too... Wait a second. I'm an asshole. This is a DC device and I'm using AC. Okay. So I have one more to show. And we will not know the voltage of this one. I don't know if anybody remembers this. This is the very first build. And all this time, it still works. Just give it a second. It'll hit. It's really not gonna hit? Well, once I turn this on, it'll definitely hit. There we go. Yeah, I still love this. This has my most efficient coil build yet, completely by accident. Made this from an old TV. Even the coil came from the old TV, the coil that I wound around it, because the old high voltage thing was broken. So we'll set that there for a second. And focus on this jolly old thing. We have a vibrator. And it definitely vibrates. Okay. Let's go ahead and... Ooh. this? Whoa, it spun. Whoa. Ow! So this is what this does down here. I'll show you. So what it's intended for is to help the energy build up in the coil and then releases it. Even though it doesn't look like it's higher powered, it should be. Yeah. And when you touch it, oh! When you touch it, it feels crazy. Like it vibrates and it sounds like bees. Oh my god, that feels crazy. Ow. This has a really incredible blue to it that isn't coming across on camera. This tube looks so beautiful. Like on camera it looks like shit. In real life it looks incredible. Anyway, you can kind of see some of the blue from the back, but it's definitely not that kind of blue. It's like a sky blue and a pinky orange. What else? What else? What else? Oh yeah, I wanted to show this thing off. This thing. If you put an antenna on this, it goes ballistic around these kinds of fields. Damn it, camera. You're focusing on the wrong thing. There we go. You can see the needle a little bit. I don't want to blow out my diode, so I'm trying to be careful. Because there's a diode on this thing. See? Cool little diode. This thing's from like the 90s or something. Here's the pedal we tried to make that needs work. Also needs a green LED and this paint scrubbed off of it. And the inside's redone because I don't know why it works. Okay. I think there's one more demo. There is one more demo. And it has to do with a light bulb. Light bulbs you would not think would do anything, but they do. They look absolutely incredible. And I could burn through the glass if I leave my fingers here long enough. This plasma will burn right through this glass. This bulb's warm right now. I know there's another bulb around here. Some bulbs do some really crazy stuff, like flash green when they shouldn't because of x-rays, I think. Oh god, I almost burned through that bulb. Yeah, it's pretty crazy. Look, now it won't even do it. Because I think I destroyed this bulb. Ow. Shit. Ah, there. Ah, yeah. See, that's one good thing about the vibrator down there, is you can do stuff like this. No clue why the bulb is green. And in real life, it is a really ghostly, arsenic-y green. But on camera, it's like, I don't know, leaf green. But oddly enough, different small light bulbs do different things. This one, if I can get it, yep, has a blue color. Very ghostly pale blue. I love it. I gotta put this back. This is an artifact. Dang it. Okay. Here it is. Yep, this thing was a cool find. I can't take it off. I can take it off. I don't feel like taking it off. Oh, I forgot there was a battery. But this is how simple this build is. There is nothing in it. There is a MOSFET and a couple of resistors. And that's it. Oh. I just felt a warm spot on this. Hope it's okay. The plans for that Tesla coil are not here. However, they are... Where is a pen? Okay. Doing the big green marker, I guess. The plans for this Tesla coil are as follows. You have it does not look like lightning. Jesus, Lord have mercy. Whatever. Okay, that's the top. Here's our coil. Here's the bottom of our coil. I think it's 24 gauge. This is 30. So like 26 gauge wire. Doesn't matter how many turns. And then on your secondary, Three turns of the thickest wire you can find. If this is your MOSFET, say this is your drain. What's on a MOSFET? A drain. Is there a collector? A gate, collector, and drain? Whatever, it doesn't matter. Drain. Whoops. This was definitely supposed to be collector. Shit. Collector. Base. Gate. And you got your battery. And then I think there is a resistor. Like that, and then like that. And that's it. That is literally it. I mean, you can find it on the internet, simple Google search, and you'll find it. But the idea is that when you plug it in, there is a little bit of current that goes through the base and out through the drain, and that will give bias to turn it on a little bit, and it will turn on a little bit, and when the magnetic field in the coil collapses, it will pulse electricity back through in the opposite direction, turning off the bias or something like that, or it'll add bias again. I think it turns off the bias, and then the field collapses. This will turn on again, bring back the field, or so have you. Lots of fun. You should build one. I'll leave you guys with the parting words of the parting puppy. Yes. We don't know him. We've never seen him in our lives. It's a grr. Look at him teeth. Look at him teeth. Anyway, good night, good day. He's really cute. He's the cutest boy. But he also is not supposed to exist, right? He is on the run. Maybe, if I did more. But I can't, I don't do enough. But maybe I should. Right, puppy dog? Oh, here we go. Boof, boof. Boof, boof. Puppy. Oh, okay. Smell your breath. He is a he. See? And that is a she. Anyway, I got 2 more I gotta go feed. Thanks for showing up and commenting. No one ever shows up in comments. It's crazy. Y'all have a good one.